My name is Megan Poole, and this is my story project. For as long as man has existed, we have questioned how the world, stars, planets, and universe came into being. Scientists like Aristotle and Plato believed in an external universe or steady-state universe, meaning one that has always been and always will be in existence. However, recent scientist discoveries confirm that our universe has a definite beginning and it is a finite universe. In 1915, it was discovered that the universe is expanding, which was confirmed more recently by scientist Edwin Hubble. Using Hubble's constant, the age of the universe is about 13.7 billion years old, and the Earth is about 4.56 billion years old. Our galaxy, the Milky Way, is just one of roughly 500 billion galaxies and contains approximately 500 billion stars, the Sun being the most important star of all to our existence. Scientists agree that our universe exists in 4 dimensions, defined as length, width, and depth, of all objects in our universe, plus time. These dimensions allow us to measure Earth and the distance between our world and other objects throughout the universe. Using longitude and latitude lines, scientists determined that the Earth's seasons are directly a result of the 23.5 degree tilt on the Earth's axis. Our solar system formed out of a large spherical cloud of gas and dust and is made up of 8 rotating primary planets revolving around the Sun. There are 4 known forces within our galaxy that prevent our planets and their moons from colliding with each other or floating away: gravity, electromagnetic force, strong nuclear force, and weak nuclear force. Our Sun contains 99.86% of the mass in the universe, which has a direct correlation with its ability to hold the planets in their orbits. A solar constant variation of as little as 0.5% would mean the end of life on Earth. To better understand our universe, a standard unit and system of measurement was needed to measure length, mass, and time. We have 2 different systems, the metric system and the British system. Famous scientist Sir Isaac Newton is known for his 3 laws: the law of motion, the law of universal gravitation, and the law of conservation of linear and angular momentum. Newton's first law of motion states that an object will remain at rest or in uniform motion in a straight line unless acted on by an external unbalanced force, such as an apple falling from a tree in a straight line until it was stopped by his head. Using this law, Newton related the concept of inertia to mass. Newton's second law of motion states if an external unbalanced force is required to produce a change in velocity, then an external unbalanced force causes an acceleration. The greater the inertia of the mass of an object, the smaller the change in motion, or velocity, when a force is applied. Newton's third law explains how 2 equal and opposite forces act on 2 separate objects. The third law led to Newton's law of universal gravitation, which states every particle in the universe attracts every other particle with a force. The product of mass and velocity is called linear momentum and is summed up with the law of conservation of linear momentum. Angular momentum occurs when objects go in a path around the center of motion of axis of rotation, such as a comet orbiting the Sun in elliptical shape. The law of conservation, angular momentum, states that the angular momentum of an object remains constant if there's no external unbalanced torque acting on it. For motion to occur, work must be done which requires the expenditure of energy. According to the first law of thermodynamics, energy can neither be created or destroyed. Energy is transformed from one object to another through the process of work. Kinetic energy is the energy of motion, and potential energy is the energy of position. When the Big Bang occurred, an enormous amount of heat was generated as energy transformed from multiple objects to create the Earth. Heat can be measured using any one of the 3 different temperature scales: Fahrenheit, Celsius, and Kelvin scale. With the exception of water, heat causes matter to expand. The different forms of energy, or phases of matter, can be classified in 4 different forms: solid, liquid, gas, and plasma. When heat is added to these different phases of matter, entropy or disorder increases, raising the kinetic energy of the molecules. Since heat only flows from a higher temperature to a lower temperature, as stated in the second law of thermodynamics, this means our universe can only move from order to disorder. Waves are the means by which energy is transferred and propagated. There are different categories of waves: light waves and sound waves. Light waves are measured by frequency and speed at which it travels. This makes up the electromagnetic spectrum. Sound waves are longitudinal and travel through matter. Waves travel in different directions, longitudinal and transversal, and vary by amplitude and frequency. The speed of sound travels much slower than the speed of light. Unlike magnetic and sound waves, light waves travel in a straight line unless they're reflected. When light is deviated from its original path, causing a change in speed as it passes through another medium, this is called refraction. Different wavelengths of light refracted at different angles causes our eyes to see colors. An example of this dispersion and internal reflection is a rainbow. In 1807, John Dalton demonstrated that matter is discrete, meaning it has a beginning and an end, can be measured. Dalton believed that the smallest measurement of a particle was an atom. All matter is composed of particles called atoms, which in turn are made up of negatively charged particles called electrons, positively charged particles called protons, and neutrons that have no electric charge. An electric force exists between any two or more charged particles. The law of charges says like charges repel, unlike charges attract. Gravitational force is much weaker than the electric force of varying particles. When a net charge flows or moves in one direction, a direct electric current, defined as a time rate of flow or electric charge, occurs. The effect produced by this charge is called electricity. Scientist Max Planck believed that matter's energy and frequency are directly correlated. By providing this, he demonstrated the dual nature of light and how it can act like a wave or particle or both. After the discovery of the atom and its contents, it became necessary to develop a method of measurement for Earth's elements. The periodic table is made up of 90 naturally occurring elements and 28 man-made ones, all having the same atomic number Z. Atoms can also be measured by the number of neutrons and nucleons, which equal the atomic number's mass. One of the four strongest forces in our universe is called the strong nuclear force, which is a short-range force that holds protons and neutrons together in the nucleus. Outside of the 10 to the negative 14 meters, this force becomes strongly repulsive. When nucleids of certain isotopes spontaneously decay, they eject radiation and are called radioactive isotopes. Atoms are the building blocks of all matter. They are usually combined with each other to form compounds, mixtures, and solutions. The law of conservation states that no detectable change occurs during a chemical reaction. No atoms are gained or lost or changed, just rearranged and form a new substance. The Earth's core is made up of four regions: the inner core, the outer core, the mantle, and the crust. The inner core is thought to be solid, while the outer core is liquid. It is commonly accepted theory that all the continents originally made up of one landmass is called Pangaea, which broke apart about 200 million years ago. Within the Earth's crust and the upper part of the mantle is the lithosphere, where tectonic plates of the rock layers interact with each other in slow motion, which leads to earthquakes. Volcanoes occur when one plate slides underneath another plate, allowing hot magma to rise to the surface. Earthquakes can also be caused by volcanoes, but most result from the movement of plates within the lithosphere. Both of these natural occurrences play an integral part in the formation of Earth's crust, creating land masses and mountain ranges. Mechanical and chemical weathering alter the surface of the Earth's crust by breaking down rock through pressure and chemical reactions. Erosion is caused by the movement of glaciers, wind, and water. Dinosaur fossils and ancient insects encapsulated in amber are critical in the dimensions of the age of the Earth. Through the use of carbon dating, scientists are able to reconstruct the events that occurred after our planet was formed. While scientists have learned much since our human existence, there is still much more to learn. Dark matter makes up 23% of the universe, and yet we know very little about it. Dark energy makes up about 72% of the universe and seems to be causing the expansion of the universe to accelerate. Science clearly tells us that our universe is winding down. The second law of thermodynamics, the law of entropy, states that energy heat process loses something to the ambient temperature. This law is commonly known as the physical law of order to chaos or disorder. In 1729, scientist James Bradley demonstrated that the speed of light is finite and slowing down. This reinforces Einstein's law of relativity that states the relative to velocity and not absolute. Since scientists now agree that the statistical probability of our universe and planet evolving into existence is mathematically impossible, they do agree that it is and we were intelligently designed. Newton's law of motion indicates that some force initiated the movement to begin our existence, but what or whom? Some scientists say God. Others like scientist Richard Dawkins, says it would have been aliens. What do you think?